Algebra 2, 6.2c, Graphing Rational Functions and Asymptotes. If you haven't seen the previous videos, I don't want you to get confused. There's a link in this video's description so you can watch them quickly, okay? And then come back to this one. So functions can be defined by rational expressions. And for the function f of x equals 1 over x minus 2, it isn't defined when the x is equal to 2. Its denominator would become a 0, wouldn't it? Why? Well, we can see what happens when we look at the graph of this function. We can see how the graph of this function behaves when the value for x is too close to 2. So I want you to remember, f of x means the y. It's the range. It's the output, okay? All right, so let's take a look at this. We've got this function of x equals 1 over x minus 2. So we're going to start by making a table of values and then graphing. So we're going to make some values that are in the negatives, and then 0, and then goes into the positives, so we can get a good range of what our coordinate points can be, all right? Then we graph these as x is 1/3, y is negative 1/5, and we graph as many points as we can, and we try to make a line. Well, what happens is, as we approach from this -3 and we get to the 1, we get a positive 1 and a negative 1. So our line is going to start here, and it's going to slowly creep along, not touching the x-axis where y is 0. It's going to creep along just below there, and it's going to start curving. Here's 1 and negative 1. See? This is undefined, so we can't graph this. This is our line for 2 right here. This is our y-axis. So if you watch, it's never going to quite touch this 2. It's never going to quite touch where y is 0 for the x-axis. When we get to 3, it goes to a positive 1. So we're at a positive 3, positive 1. Here's positive 3 and positive 1 right there. See? Let me get a little bit closer for you. And we jumped from down here to up here on our graph. And it's not touching. When we get to 4, we're at a half. When we get to 5, we're at 1/3, and it never quite touches where y equals 0. So our line approaches x equals 2, but never crosses it. And our line approaches y equals 0, but never crosses it. It kind of curves, see? So what happens to the function of x as x gets close to 2? Well, as x approaches 2 from the positive side, it gets larger. And as it approaches from the negative, it gets smaller. See? And the graph of this function will never cross the x-axis because there's no value of x that the function of x equals 0. X equals 2 and y equals 0 are both asymptote to the curve. X equals 2 is a vertical asymptote, and y equals 0 is the horizontal asymptote. See that? Never quite touches, see? So a line is an asymptote to a curve if the curve approaches the line but doesn't intersect it as the absolute value of x or the absolute value of y becomes large. Now here's another thing. If you have to graph a function like the function of x equals x plus 1 over x squared minus x minus 2, all you have to do is factor the denominator first. We get x minus 2 times x plus 1, and that gives us the x plus 1 over our denominator, x minus 2 times x plus 1. We can see these are both the same. So what we get is a 1 over x minus 2. And you know what? That's what we were making the table of values for, 1 over x minus 2. See? So you can just factor first when you have something like this, okay? Our next video is going to be 6.3a. We're going to talk about how to simplify complex rational expressions. I'm going to add this video to the Algebra 2 playlist so you can use it for studying. And I'm going to put similar videos in from Algebra 1 that will help you along with the videos for 6.1 A, B, C, and 6.2 A and B that we just finished doing. So you need to watch every single video, otherwise you're going to get lost, okay? It's like walking into the middle of a movie and not knowing who the killer is or what happened in the story, all right? So hopefully this was helpful, and I'll see you next video. Bye.